Okay, these are the notes for 7-1 for traditional geometry. What I would like to do is start by reviewing some Algebra 1. So there are 6 equations here for you to solve. I'd like you to solve each of them by factoring or by using the quadratic formula. I have done both for you in the answers, but I would like you to try these. So that means you need to push pause and you need to try these to solve these quadratic equations. And then you can come back and check the answers. But again, I need you to push pause and try them yourself first. All right, on the screen here, I have the first 4. If you're factoring, you want to make sure it equals 0, regardless if you're using quadratic formula or factoring. In number 1, you can see I factored it. That's from chapter 5 from Algebra 1 there. If you can't remember how to factor a trinomial, just go on YouTube and Google it or search up a video and it'll refresh your memory. So I factored the left side. So x plus 6 times x minus 1 is the same thing as x squared plus 5x minus 6. I just put it in factored form. And I know that when I multiply two things and they equal 0, that means one of the factors must be 0. So I said, okay, what could I plug in for the first factor to make it equal 0? And then what could I plug in for the second factor to make it equal 0? And when I solve those, I get negative 6 and positive 1. And if you plug in negative 6 for x or a positive 1 for x, you should get 0 either way. I solved the same equation with the quadratic formula. Again, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Perhaps you learned a song for it. If you didn't catch what I just said, again, just go on Google, look up the formula, it's there. Your a is the coefficient in front of the x squared. Your b is the coefficient in front of x, and your c is a constant. And this is all after it equals 0. You must make it equal 0 first. So you can see I plugged in my negative or opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Just using order of operations, I simplified. At the very end, you'll do negative 5 plus 7, which would be 2 divided by 2. That's where the 1 came from. And then your second answer would be negative 5 minus 7, which is negative 12, divided by 2, and that's where the negative 6 came from. You can see the other answers here. I saw by factoring and by quadratic formula. In this one, I cannot factor number 4. That's not an option to solve it by factoring, so I had to use quadratic formula for that one. So quadratic formula will be useful almost all the time. Factoring is nice because it's a little faster. Number 2 may look a little different than you're used to. I factored out the greatest common factor of x, and then my factors are what are you multiplying? And I'm multiplying x and x plus 8. So what would make this factor equal 0? Well, 0. If I plugged in 0, it doesn't really, 0 times whatever that is 0. And what would make that? And if you need more, just push pause. We can always check the work. Over here are your answers for 5 and 6. Had a little bit more work to do with those to make them equal 0. Multiplying this binomial, if you want to do the area model, it's y minus 5, like the squares, you can do that too. So here are the answers again. If you need more time on them, just push pause and you can check your answers. So that leads us into our beginning of our discussion. We're going to talk about similar figures. And to start, we need to talk about the basics of similar figures, which are ratios and proportions. A ratio is a comparison of two quantities. Proportion is a statement of two ratios that are equal. Okay, so saying two ratios are equal to each other. So properties of proportion, you may need to check if you have the printout. I think this one right here is slightly different than the one you have. I think I had a typo on the printout. So if we start with this particular proportion, A over B, which is a ratio, equals C over D, and we're given that that hypothesis is true, then this is the most popular one you know, which is just saying that the cross products are equal. A times D equals B times C. In the second property of proportion, if you kind of look and compare that to the original, you'll see they said if I flip the left side over to stay equal, I have to flip the right side over. So that's that one right there. In the third property of proportion, which is right here, they left the A and they left the D and they switched the cross products. So basically they're saying you can switch the cross products. And the last one says that you can add the denominator to the numerator and leave it over the denominator, and that will equal doing the same thing to the right side, adding the denominator to the numerator and leaving it over the denominator. And you should know these, so write them down or so that you have them to help on the next slide. So in the next slide, this is my given proportion. X over Y equals 5 over 6. So based on that proportion, you're going to use the properties to fill in these blanks. So you're not going to get like 7 all the time or something. You're just using the properties of proportion to make sure the left and right sides stay equal, stay balanced, stay the same, which is what equals means. So I'm going to ask you to push pause and please try those now. Trying them now will help you learn them better than just pushing on to the next one and getting the answer. So try them now. If you make a mistake, that's great. You'll learn a lot from that. So push pause now. Right, here are your answers. Cross products are equal. They flipped the left, so I flipped the right. They took the 5 and moved it to the y, so I put the y where the 5 was. And add the denominator to the numerator, keep it over the denominator. You can see I did that here. In the next one, we're solving proportions. And to solve a proportion, you've done this before. You did it in Algebra 1 and you did it in pre-algebra. You are going to multiply the cross products and set them equal to each other. They get in progressive difficulty, so please try these on your own and then come back to check your answers. So please push pause now. Okay, here are your solutions. You can leave it at 60 over 7. If you have the decimal or the mixed number, that's fine too. You can see my work here for this one. And don't forget, all your answers here, you should be able to plug them in and get equivalent fractions. So if I plug in 3 here, I get 3 plus 3 is 6. And 6 over 8, is that equal to 3 over 4? Yes it is. And the same for all of these here. And down in letter D, you can see where I had to multiply binomials. I had to make it equal 0. I chose to solve it by factoring. You also could have solved it by quadratic formula. If you did, you should have gotten the same answers. Again, if this is moving too quickly, just push pause. You can check your answers or copy down the correct work. All right, and the last one, a scale compares each length in the drawing to the actual length. You've done these before in a scale drawing. We've done blueprints, I know. I believe you did some work in Tech Ed with that as well. So please answer these questions and then come back and check your answers. All right, here are your answers. This one I probably should have put miles. Okay. And these are used on maps as well, as they said here. When your apps for Google Maps or whatever you're using, they are using a scale factor to help you determine where you are. So those are the notes for 7-1. The homework is listed in the announcement, so please work on that.